Okay, so the purpose of this video is to show how our program works, and our program is designed to kind of get your feet wet using stepper motors and real-time interrupts to control those stepper motors. So here's the equipment that we'll need to run the program. We have the stepper motor itself, which is in this case a 4-lead. They make other types, but the 4-lead is the easiest to use with the board. You don't have to figure out which 4 leads you have to plug in. We also have a power supply, a 5-volt power supply to plug in and power the stepper motor externally. Then we have a USB cable to communicate to the computer and send the program to the board. And then on the board we'll be using the push buttons, so switches 2 through 5, and also the LCD display. And you will need a screwdriver to connect the leads from the stepper motor to the board on the connections labeled M1 through 4 down at the bottom. And you'll also need to connect the power supply to the connections right next to those M1 through 4 connectors. So our first step will be to make sure that we have the program file, which I already have in place, called RTI. But you'll need to make sure you have the correct lab stationery downloaded and ready to go on your computer using CodeWarrior. So here I'll just go ahead and open up the file we've already made. And you'll want to go to the main where the program is located. And this is the program. So we've tried to leave lots of comments so it's pretty easy to follow and you know exactly what's going on. But there are a few notes about using the RTI. With the current stationery that we have, when you go to use the RTI, it's actually declared twice, so it throws an error. To combat that, we will come down here to interrupts.c, and if you notice right there, the interrupt void, real-time interrupt void, is commented out. So when we first started writing this program, it looked like this, and so we just put in the comment, and it was no longer over-defined. So, and of course, you will connect your board and then hit F5 to compile. And it'll show that we have no errors, a few warnings, but that's no big deal, and I'm currently not connected, but then once you are connected, you'll press this green arrow. So as you can see, we have the 5-volt power supply wired into the board, and the stepper motor wired in. For this particular stepper motor, it's a 4-lead that you might find in the lab, and we have the brown lead going into M1, the orange going into M2, the red into M3, and the yellow into M4. It might take some playing with to ensure that those are properly connected. You can see how they go into the back of the motor and split to their separate ways. So we currently have this program running, and it's telling us to initialize by pressing a switch. Again, your switches are down here. So we'll just press a switch. And we are currently rotating counterclockwise. We'll press switch 3. And now we're rotating clockwise. Now we can speed up or slow down. So by pressing switch 4, we've sped it up. If we press switch 5, we will slow it down. Speeding up, slowing down, and we can reverse our direction. And it is possible to reverse this at speed. And you can see the LEDs show the process that the motor is actually going through. So the different steps. Alright, we hope that this video has helped shed some insight into using the stepper motor and real-time interrupts to control the stepper motor. So, thank you.